So in this tutorial we're going to have a look at rounds and chamfers, and we're broadly going to follow the procedure outlined in this primer. So if you want to get this primer open in the background, just for your reference, that might be useful. So we're going to have a look at the round feature first, and in order to add a round feature into a part, the part has to contain some geometry first. So we're going to quickly create this revolved feature that it's showing here, just so that we have something to add the round feature onto. So we'll just get rid of that PDF, quickly create a new part here, and we're going to sketch the shape of that revolve quickly. I'm just putting a center line in here because obviously with it being a revolved shape we need the center line, and then just quickly sketching in the revolved shape. So just because it's good practice, I'm gonna dimension this up so that I have control over this, not the system. It's always good practice to dimension your parts and add constraints so that you, the user, are controlling the shape of the geometry rather than the system doing whatever it wants with it. So there you can see that that's a rough approximation of the shape in the primer PDF. And what we're going to do now is we're going to add a round feature to that. So if we click on the round feature button up here, and you can see that because this first tab is highlighted, it's asking for some input from us, the user, and the input that we're going to give it is this edge here. And you can see as soon as I select that edge, it shows me a preview of what the round feature is going to do. So if I view that from the front here, you can see that it's creating a nice smooth transition from this cylindrical face here up to this flat face here, and it's using a portion of a circle to create that transition. So you can see that that's a circular arc that's in this case swings through 90 degrees because this face up here is vertical, this one's horizontal, so it must swing through 90 degrees in order to bridge the two in a smooth way. So if I want to change the size of that round, I've got a text entry box up here. I can scale it down if I put a smaller figure in there. So that's a 10mm round. So that 10mm relates to the radius of the round. And if I want to increase the size of it, I can enter a figure up there. I've also got these drag handles. If I want to dynamically change that and see what that looks like on the preview, I can do that as well. And then I can just double click back in the box and just round it to whatever figure I need it as. So that's essentially the round tool. There are other options in there, but for most situations the circular round is the one that you're going to want to use. So if we just get the PDF on screen again and have a look at the next section here. So you can see that it's telling us to insert a chamfer on this front edge here, and once we've inserted the chamfer, we can enter a value in the chamfer box, and that will control the size of that chamfer. And it's telling us that the type of chamfer that we should create is a D by D chamfer. So that's one dimension in the horizontal as we're looking at it, one dimension in the vertical. So we'll do that next. So we can, just like the round, we can pick the chamfer tool, and just like the round, it's asking for some input in here, and we're going to give it this edge as our input. So you can see that it's giving me a preview of quite a large chamfer, and what I can do, you can see that I have the dimension by dimension chamfer D by D, which basically means I only have to put one value in this box and it will size the chamfer accordingly. So if we look at that chamfer square on from the front plane here, you can see that it's a chamfer at 45 degrees, and that's because the horizontal dimension of that chamfer, so in this direction, is equal to the vertical dimension of that chamfer. So you get a 45 degree chamfer from that. There are a few other types of chamfer. We could have a D1, D2 chamfer, where we can vary the horizontal independently of the vertical. So you can see that's what I'm doing here. You can put two different values in, hence D1 and D2. Or you can have a chamfer that's defined with the angle and one distance. So you can see that that's what that chamfer's doing. So I can have a 45 degree angle, I can have a much shallower angle, I can have a much steeper angle, you can see that's a much steeper angle, and I can also vary the depth there as well. So let's just check back with the primer sheet again. So that's pretty much rounds and chamfers, the basics covered. Next we'll create this extruded shape up here, and we'll look at full rounds. So we're just going to quickly create that extruded shape. So if we create a new part file and then sketch on one of the planes, the shape was symmetrical, so we can put a center line in there, and it was just a series of lines tapered toward the top and then were truncated like that. So because it was symmetrical about the center line, I'm going to mirror that geometry. So I'm going to select it all first and go mirror, and then select the center line, and again I'm going to put some dimensions on there just to lock the size and the location of the thing down. So there you go. That's the shape. I can OK the sketch now, create the extruded feature from that. Again, for these tutorials, the actual figure doesn't really matter too much, but if I wanted to enter a precise figure, I could tap that into that box there. So you can see that that is a rough approximation of the extrude in the primer. So what we're going to do next is we're going to use the round tool again, but rather than clicking on a single edge, we're going to click on this edge over here, hold down Control, and then click on this edge over here, and then rather than give those two edges a diameter, we're going to change the type of round to full round. And if we do that, what the system is doing is it's picking a radius of curvature for those rounds that mean that the top surface of the part is totally eliminated. So whatever size these rounds have to be in order to meet each other, that's the size that it sets them at. So the user no longer has any input in terms of the radius curvature of the rounds. So that's a full round, which we can turn that back off again if that's not what we need, and vary the size ourselves, or if we switch it back on, it's a full round. So the rounds run into each other in a smooth fashion.